Okay, so problem number 22 on these practice problems. Because it says percentage. Okay, so I'm just going to say that the town has 80,000 people. That's reasonable. So if the town had 80,000 people, somebody take 44% of that. $35,200. This is also one of those things where we have a high number, so we would just do the same again, and rather than counting down. Okay, and to give you the illustration, this is the same as 44%. We just saw that. If we took that number and now multiplied by 79,999 with 35,199, it's still going to come out to what? 44%, isn't it? So by just having that first one, because it's a huge population, isn't going to make the difference, and therefore I'm still going to use the 0.44.
So basically with this one, if we need percentages, we would want to do it this way here.
Mm-hmm. Or
there is some way that you would, like, I remember it was from last semester in the summer, you would do it like the way that.
Right, if you had the exact number of people,
Okay.
and my sample was below a certain percentage, okay? But I don't even have the exact number of people, okay? So I have to go on my percents. And this is the same as 4,400ths times 4,400ths. It's another way of writing it. But I wouldn't want to count that down because that would be making an assumption that there was only 100 people who lived in the town.
I thought I had it right. Because it was very close the way that I did it. I got 31%.
I'm glad you asked that question. Yes. So here's another example. The weather forecast comes out, and they really do base their percentages and their predictions for weather on past experiences. So in the past, when these conditions happened, 80% of the time we got a big snowstorm. That's what they really do make those predictions on. So when we have snow, let's say that there's a 50% chance that school will be closed. So what is the chance that it will snow and school will be closed? Okay, but I only have an 80% chance that it's going to snow. I only have an 80% chance it's going to snow. And if it snows, 50% chance that the school will be closed. It has to be an and situation. And what does and mean? Multiply. So can I change it? Can I count down in any situation like that? No, I'm simply going to say 0.8 times 0.50. So there's a 40% chance that school will be closed based upon 80% chance of snow and 50% chance that the school will close if there's snow. Okay? So when I'm doing percentages, you don't want to count down. Maybe that will help. When you're given two percentages, you're going to have to just stick with the percentages. Okay? Okay.
And I guess it was 23, because 23 was similar as well. And I'm not sure in manufacturing process has 70%.
Okay, so number 23 says a manufacturing process has a 70% yield, meaning that 70% of the products are acceptable and 30% are defective. If 3 of the products are randomly selected, find the probability that all of them are acceptable. Exactly the same thing, yes. Because, Yeah, I'm going to take 0.7 times 0.7 times 0.7.
None of this nonsense.
Right. Not 70 over 100, then 69 over, because again, it's percentages. I don't know how many products there are. There could be 100,000 products. See,
So it's just 0.7 to the first power.
0.70 to the third power, exactly.
And next is the same thing.
The next one's the same thing.
I would imagine
If it's a percent,
60% of adults have health insurance. What is the probability that 4 adults selected at random from the town all have health insurance?
correct.
You would do 60.66 to the fourth power.
0.66 to the fourth power. Again, it's percentage. I don't even know how many people are in that town. So I'm going to have to do with just percent. Very good. Another one?
Right? I feel like I'm like holding it.
That's okay, but it's fine. I'm glad you're asking questions.
There we go.
Which one?
25 items.
25. 25 says you are dealt 2 cards successively without replacement from a shuffled deck of 52 playing cards. Find the probability that both cards are black and express your answer as a simplified fraction. Okay, so
This is the way I was talking about that.
yes,
Now we're doing it.
yes, because I know how many cards I had to start with. I know the specific number of cards I have to start with. I don't have a percentage, okay? So I know that there's 52 cards in the deck, and I want to know the probability of getting 2 black. Well, how many are black and how many are red? 26 are black, 26 are red. So in my first draw, I get 26 out of 52. I take that card out. Now how many cards do I have left? And 25 of them are black. Okay? That help? So that's going to be 1/2 times 25 over 51, which is going to be 25 over 102. Okay? How about another one? 26. I'm glad you have it printed out now that I've got it there. Okay. An IRS auditor randomly selects 3 tax forms. I have exact number of 49, so I'm drawing from 49 returns, of which 7 contain errors. What is the probability that she selects none of those containing errors? Okay. Yes. So she's going to select 3. 49 returns, of which 7 have errors. What is the probability that she select none, those containing errors? Do they do it backwards? Is that the right answer?
Yeah, this is wrong. I swear, this is one of the ones that I need to help with.
Okay, good. Well, okay, good. So I had 49 returns. 7 contain errors. But I want the probability that I'm going to select 3 without errors. Well, if I have 49 total and 7 of them contain errors, how many don't contain errors? 42 are perfect. That's mine. Mine's in that group, right? We hope. So if I'm going to now select 3, the very first time I select, I have a total of 49 to choose from. And how many are perfect? 42. Yes. Again, put yourself into that position. I've got 49 I'm choosing from. Probability of choosing perfect. How many are perfect? That's what you should be thinking Wednesday on the test. Think about it. Think about putting yourself there. Okay, what's happening? What is physically happening? Here they all are. I'm choosing one. Okay? So then my next one down, right? I don't have 49 anymore. I have 48, and only 41 are perfect. Then the next draw, I have 40 that are left that are perfect out of 47. And by the way, if it asks for a simplified fraction, always reduce your fractions as you go because it will help you a lot. So can I reduce 42 over 49? Yes. It can be reduced to what? 6 over 7. Absolutely. 41 and 48? I don't think so. But how about 40 with 47 or 48? Are they both divisible by 4? We can start there. They're both divisible by 4, aren't they? So if I divide this by 4, I get? If I divide this by 4, I get? Can I go further? Because I still have 10 and 12, and I know they're reduced. They can be reduced, and this one would become a 5, and this one would become a 6. Can I do more? Look at that. 6 and 6. Wow. That really helped, didn't it? Especially if to give the lowest simplified fraction. So in other words, on your test, think smart. You guys can do that math. And if I multiply 42 times 41 times 40, and then the denominators, and then I'm going to have these huge numbers, and then I got to look at reducing that fraction, I'd be here a long time. But if you reduce now, it's much, much easier, correct? So now I'm left with 5 times 41, which is, I'm sorry, 2 or 5. And I'm left with 7 times 47, 329. Okay? Much easier than doing that whole thing out and then reducing, right? You'd be there a long time. How about another problem?
I was thinking 20.
29.
All my different ways, and I tried to figure it out.
Okay. An unprepared student makes random guesses for the 10 true-false questions on the quiz. Find the problem that there is at least one correct answer. There's the clue. At least. At least one correct answer, which means they could have one correct answer, they could have 2 correct answers, they could have 3 correct answers, 4, 5, and all the way up. So because I have all those possibilities of having at least one correct answer, I'm going to use the complement and subtract it from 1. Those are the key words. So at least one correct. What is the opposite? There's none correct, right? So I want to say 1 minus the probability of none correct, because it's at least. So I'm taking away the possibility from the whole that I get every single problem wrong. So 1 minus true false, so it's a 50-50 chance, right? So you can put in 1/2 or 0.5, either one, it doesn't really matter. And how many are there? 10. So it's 1 minus 1/2 to the 10th power. And the key words again are at least. Okay? Because again, I would have to, if I didn't do the complement and subtract it from 1, I'd have to find out the probability of getting 1 right. Then add it to the probability of getting 2 right. Then add it to the probability of getting 3 right. So that would be a long set of computations. But if I just say, hey, subtract it from of getting none right, then I have all those possibilities taking place. Okay, good, good. Another one.
I think 30 is very similar to the, to, let's go into this. I think it's similar to, I think that's why I got it wrong.
You're absolutely right.
Yeah.
Yeah.
It's the same.
It's a reading thing, it wasn't a math thing, right? Yes, that's the other thing. You've got to read very critically. You have to read very critically. What is it asking me? What is it asking me? Mm-hmm.
So in this case, it would still remain, we would take the 40 minus the 18 and then go like...
Mm-hmm. So this problem, number 30, is the one we're talking about. A sample of 4 different calculators is randomly selected from a group containing 18 that are defective and 40 that have no defects. So let's go ahead and do that one. So I'm selecting 4. I have 18 that are defective and 40 that are...
No, I think it says a sample of 4 different calculators is randomly selected from a group containing 18 that are defective. We would calculate that at least one of the calculators is defective. We only pick 1. Because that's we're kind of thinking of too, but it says like they were testing 4
At least one of the 4 is going to be defective. What's the possibility that at least one of those 4 that you pick?
Right. What is the probability that at least one of the calculators is defective?
Okay.
So here we've got that at least again going on. Okay? I want to know the probability of at least one being defective. Of course, I could have 1 defective, I could have 2 defective, 3 defective, or all 4 defective. So instead of doing 4 different calculations and adding them together, I'm going to take the complement and subtract it from 1. So I've got 1 minus the probability that at least 1 is defective, and I'm going to say that none are defective. That's the complement, right? None are defective. So I've got 1 minus, well, how many total calculators do I have there, though? Be careful. I have a total of 58 calculators. How many are perfect? 40. So I've got 40 out of 58. And how many am I taking? 4. So it's 1 minus 40 over 58 to the 4th power. Again, anytime you see that at least,
If you take 4, if you divide 4 by 58, I think it's 0.06. It's greater than 0.5. So it's subtracted. To do the subtraction rule instead of raising it to the power 4. So can you just 40 is to the power 4?
So, are you talking about putting this in your calculator? So I would literally put in my calculator, in my thing, I would put a 1 and a minus, and I'd put parenthesis, and I'd put 40 over 58, parenthesis, and go ahead and put right there to the 4th power.
Yeah, I'm saying raise, there's a rule that says raise it to this part, just maintain one probability instead of saying 40.
So I think you're saying when you round it,
Yeah, I know. I'm saying that to take just the first probability and then you raise it to the power. If there's a rule that says if the sample space that we choose is 5%, it's less than 5% of the total population, then that's when we use that.
the countdown thing.
So I divided 4 by 58 and then it is 0.86%, which means.
So it is greater than the 5%. I don't know why it shut down on me.
Oh, also, we were saying that already on the answer key, our answers don't match up the calculation.
Okay. Is this number 30?
Yeah.
Okay. So as George is pointing out, that because I have a number here, it's going to come out. So it should be 39 over 57 times 38 over 56 times 37 over 55. Yes, he is. See? Yay, George. And honestly, on your test, I would probably accept either answer.
That's the way that I was referring to before.
Mm-hmm.
Okay.
Exactly. I would accept,
It's
yeah.
not considered not with no replacement. The way that you did it earlier, that would be with replacement.
Correct. Correct. Did they say with or without replacement on that?
It didn't even.
Okay. Yeah. So a very good point is it didn't mention if this was with or without replacement. This would be what? With replacement.
That's without.
And this is without. Exactly.
So on a test, it doesn't specify.
If I don't specify, then I would have to take either. I'll try to do better than that, but I wouldn't guarantee it. Yep, I would take either one. Absolutely. And if there's a problem, I think I told you that from the beginning. If there's a problem that I give on the test that every single solitary student gets incorrect, then everybody gets credit for it because obviously I didn't cover it and there was something wrong with that problem. And I've done that 1 or 2 times. So, any more?
Anybody else?
Number 38. What's 38 say? 38. A musician plans to perform 8 selections. In how many ways can she arrange the musical selections? So, the word what gives me the clue? Arrange. Arrange. Because I am arranging them, order matters. Since order matters, it's considered a permutation. Okay? So we can do it, think about it 2 different ways. We could say 8 factorial, because I'm going to use all 8 selections, right? So that's why I'm going to say 8 factorial. But you'll also notice if you say 8 permutation 8, it's very equivalent. Very equivalent. Okay? So 8 factorial on that one.
And the one this one here reminds me of the one we did in class. When I did it this way, I got 56, and then the answer I do believe is
Oh, this one, I think the answer's wrong on
I
here.
remember from last time.
Yes, the answer on number 40 is incorrect.
I forgot what me and Dylan got when I did it last time. So I did it this way because we did something like this in class before. If they're going to fight each other. So I
Right.
thought it would be 8 times 8, but it's not that.
Right. So number 40, 8 wrestlers compete in a competition. If each wrestler wrestles one match with each other wrestler, what are the total number of matches? Anybody? 3? Seven?
No, because there's 8 wrestlers, and each one is going to wrestle each individual one.
I have 7.
You have 7?
Each one is wrestling the
Each,
Yeah, so
it's,
4
it's,
with.
okay, so
I think there's more than that. Don't you think, Ms. Williamson?
so let's work it out.
If you have one's going to wrestle 2, 3, 4, 5, 6, 7, 8. If you have two's going to wrestle 1, 3, 4.
But you can't count that one again. See, there's where you have to be careful. There is exactly where you have to be careful. So we'll just call them 1 through 8. Is that cool? Okay. So 1 has to wrestle with 2, 3, 4, 5, 6, 7, and 8. How many matches is that by itself? 7, right? Do you agree? Okay. Now let's go to wrestler 2. But wait a minute, wrestler 2's already wrestled number 1, but they have to do what? 3, 4, 5, 6, 7, 8. How many matches is that? 6 more. We seen a pattern? Okay, so wrestler number 3 already has wrestled 1 and 2, but has to do 4, 5, 6, 7, 8, which is another 5. Everybody seeing what's happening? Okay, so wrestler 4, how many more am I going to have to put here? 4. Wrestler 5, 3, and wrestler 6, 2, and lastly wrestler 8, 1. Nope. Wait a minute. I forgot 7. Would be 1. And 8 would be none. Because he can't wrestle himself. And if you add up all those, you come to 28? $28 matches. Yep, the answer key is wrong on that one. Okay? Aaron, you had one. That was it. Okay. That was the one. Any others? Everybody does okay if it's a conditional probability given this. You're okay with those? So what's the probability of drawing a jack given you've already drawn a queen? Probability of drawing a jack given you've already drawn a queen. That's, remember, you have to read that given as that line. What's the probability of drawing a jack given you've drawn a queen? So if I got it 52 cards and I've already drawn one out, how many cards do I have left? And if I drew a queen first, how many jacks do I still have? 4. It would be different, wouldn't it, if I said probability of drawing a jack, given I already drew a jack. I already have drawn one out, so I only have 51 cards left. And the first time I drew a jack. So now I only have 3 to draw out of the 51 that are remaining. That's a given situation. Okay? You guys, we did a lot of practice with reading the charts. Right? So if you remember the drug charts of the users, and you only do that population, right? Okay. Trying to think if there's anything else. Are we okay on counting, whether it's a permutation or a combination? Possibly.
If it's a kind of question, please give us like how many things. I'm going to confuse with that.
Okay, good. So, like if I give you a card question, tell you how much are in the deck.
Yeah, it's not just confused with jacks and queens. Like, I'm not.
Okay.
Really know all that.
Okay, that's absolutely fair. Yeah, it's absolutely fair. Yeah. So how about if I gave you the probability of, let's see, there are 7 black marbles, there's 5 blue, and 2 green. Find the probability of drawing 2 blue. What's the probability of drawing 2 blue? So this is exactly the type that I say, put yourself in that situation. How many total marbles do I have? 14. So the first time I pull one, my chances of pulling a blue one are 5 out of 14. There's 5 blue marbles out of a total of 14 marbles there. Okay. Is this an and or an or situation? And, because I have to draw a blue and draw a blue to get 2 blue. And with and, we always use. So now the second time that I'm ready to draw that marble, I don't have 14 marbles left. I only have 13. And because I drew a blue the first time, I don't have 5. I only have 4. Does that make sense? But if I wrote it this way, probability, I'm not going to say it, I'm just going to write it, okay? Because you're going to have to read it. So I could write on the test the probability of black/green. You have to think about what that means.
That line means given.
Given. That line means given, and that's how you need to read it. The probability of drawing a black given I've drawn a green. Okay? The probability of drawing a black one given I already drew a green one. If I already drew a green one, do I have I just want to give you the answer. This is why I don't want to answer questions on the test, because I blew up there. I wrote out of math. I don't have 14. I have 13. The first one I drew was green, right? So how many black do I still have? Okay? See the difference? Also, I could say, give me the probability of drawing a green given I already drew a green. That's really the same as saying the probability of 2 green almost, right? But I already am taking care of that green. I'm not going to calculate that in. Probability of drawing a green given I already drew a green. What's that going to be? 1 out of 13, exactly. 1 out of 13. Is it getting better? Good. Probability makes you think. Really makes you think. I haven't written it yet, so I don't know. I had these grand plans of getting here. I was here by 8 o'clock and I have spreadsheets I had due to that conference, and they were waiting for me, and I had to run out the door. So, Sylvia?
So is this how you would recommend also the 27?
Let's see, 27. 27. Okay, here's the table. The table below describes the smoking habits of a group of asthma sufferers. If 2 people, different people, are randomly selected from the 991 subjects, find the probability that they are both heavy smokers and round to 6 decimal places. So, all of them are asthma. And I have a total of 991, and I want to find that they are both heavy smokers. So my heavy smokers are what? 86 out of 991. And then I want to do that, how many? 2? 2. Yes.
Is there any other way I could look at it, or is this like the easiest way?
That's the easiest way to look at it.
And this is the one that we can do it like that because you have the total.
You have the actual total. You have the numbers.
0.44.
Right. Right. If you had the percentages, you're going to stay with the percent. You have to. So,
For example, in this situation, you have 2 smokers, so that if you have 3, you do 84 over 899.
right. Correct. Correct. Now, here's another question that I could ask about this particular chart. And this is what we've had here as well. Now, you know where I'm going, right? Because I very well could say, fine, is it, no, I don't have, I have another one that's on there. Okay, 31 is like that. But let's first, I'll make something up for 27 because everybody's looking at that table. So for 27, if I say, find the probability that I'm going to choose 2 women given that I am looking at heavy smokers. Probability of choosing 2 women given that they are heavy smokers. So how many total heavy smokers do I have? I only have, now I'm only talking about those 86 heavy smokers, see? I'm only talking about those heavy smokers, so I've eliminated the rest of the population from that table. I'm only talking about those 86 heavy smokers, and how many are women? 44, so it'd be 44 over 86 times 43 over 85. So that's why you have to read what population, what things am I thinking about, okay? I could say, what's the probability of choosing a non-smoker given they are women? What's the probability of choosing a non-smoker given they are women? So what population am I using now? Only women. What's the probability of choosing a non-smoker given they are women? So it's out of the women. So I'm going to look at 525 total, and how many of those, how many of the women are non-smokers? 446. Okay? So you have to read that given part, and that's going to tell me the only part of the population that I'm using. Okay? So it is critical reading. It is critically reading the problem as well. How about another one? 37. 37. How many three-digit numbers can be formed using the digits 1 through 7? And I want a three-digit number. And I'm sorry?
They can't be repeated.
They can't be.
Oh my goodness.
It's really not happy with me today at all. I don't know why. Okay, so I can't repeat, so that is what, telling you what? It's without replacement, right? Saying it's without replacement because I can't repeat the digits. In other words, I can't have 222. That's not a valid three-digit number. Okay? So, does order matter? Yes. Why does order matter?
You can't use the same number.
I can't use the same number, but is there a big difference between 765 and 567? Are those two different numbers? Sure. So order does matter. How many numbers am I choosing from? 7. And we've decided that order matters, so it's a permutation. And how many am I making? 3. Okay? For 27? It could be that did you take 86 over 991 times 85 over 990? But I had 86 to draw from. And 86 over 991 is more than 5%. Okay?
You didn't give us any problem for that.
Yeah. From the whole sample. So I'm only drawing 2, and that's going to give me such a small amount. I see your point. I think I would take either one on that. Yeah.
What is he saying?
He's saying that my sample is less than 5% of the population.
Oh, I see. So it's fine. So he's doing it like that.
Yep. Sometimes they intend for you to do it their way, even though it doesn't follow rules. I get it. Yeah, I get it. All right, any others? Everybody's okay? Number 28. Provide a written description of the complement of the given set. I'm probably not going to have you describe what the complement would mean.
But the complement would be that
It says when several, are edited, none of them are found to be free of errors. The complement is that all of them would be
free of it.
correct. All of them would be free of errors. Correct. They'd be the opposite.
What about 36?
36. 8 baseball players are to be selected to play in a special game. The players will be selected from a list of 27 players. If the players are selected randomly, what is the probability that the 8 tallest players will be selected? Okay, that was like the one we did with the youngest, I think. So I'm choosing from 28 players. Is that right? The right number? 28? 27? I have 27 players, and I'm going to choose 8 players. And I want to know the probability that I choose the 8 tallest players. Okay, so when I choose these players, do I have to choose them in a specific order?
This is like a two-step question.
It is a two-step question.
It's random.
Yeah, the order doesn't matter. I could choose the 8th tallest person, then the 1st tallest person, then the 6th tallest person. So the order that I choose them doesn't matter. Okay. How many possibilities? So order doesn't matter, so I'm going to say 27, combination, choose 8. And what is that number? That sounds like it's wrong. 222? Or did I write it wrong? That's correct? Okay. So there's 2,220,075 different combinations of that I could choose. Okay? How many groups would have the tallest players? 1. Because we already took out the possibility of doing different orders. So we've already taken that into consideration. It doesn't matter what the order is.
I think if it said maybe we had to like find like how many combinations first, then it would be like, oh, okay, because it's a two-step question.
This question, if the person is because we don't know how many tall people are inside that.
It doesn't matter because, no, it doesn't matter because if I have 27 students, can I line them up from shortest to tallest? And I could then have the 8 tallest.
But I'm saying that it changes, you can just feel that the teams will all come from.
Yeah.
George likes to complicate these problems. They can all, right, he's saying they could all have the same height. Well, I guess we have to get,
16 of them have the same height and then
we'll measure their heights with micrometers, okay? So they won't have the same height. We will find a way that they are the micrometers. We're going to get them out there to find out. George, I like the way you think.
So it should say the players are selected randomly and they're all different heights.
And they're all different heights. There you go. And there's another question that we had that, I went back and forth over, it was about, was this baseball players?
Yeah.
Okay, this is basketball players. selecting 5. But the problem is everybody has a different position they play. So if you start complicating it with the positions that they play, right? Because then it would be a permutation because they would each be assigned a different position.
It's like you want to think about it, but don't think about it too.
It's crazy. So and if you're taking the test and you're going, okay, is this because they're going to be assigned a position or not a position, and it's not obvious, then I bring that to my attention and I'll make an announcement to the whole class. Yeah, just to make sure. Yeah, we went back and forth on that multiple times.
There's a question on it says 414 section 4.6. It says a few steals ATM card.
Oh yeah.
You have it?
Yes.
It's at 4.6.
4.6. Question 1. A thief steals an ATM card and must randomly guess the correct 3-digit PIN from a 9-key keyboard. Repetition of digits is allowed. What is the probability of getting a correct guess on the first
I
try?
tried this and it wouldn't give me the right
I think
answer.
that one was a 7-digit secret code.
Well, on this particular keypad, they're saying you only have 9 possibilities, right? So, my first digit, how many possibilities do I have? 9. And the second one, no, because I can have repetition. It says I can have repetition of digits, correct? So the next time I choose a digit in that PIN, what's it going to be? How many different can I choose? 9. And how about the third time? 9. So it's 1 over 9 to the third power.
But my thing is, it's weird because I thought it would be like you could use the combination, but it gave me it was wrong. It wasn't right. I thought it would be combination. But you
No,
can't
it's
do
not
it
gonna-
that way.
You have to do it this way because I can't even use a permutation because order would matter, but I have replacement. And permutation assumes that it's without replacement.
You gotta make it this.
Right, because it says I can have repetition. I can have repetition. So that would be 1/9 to the third. Yep. Exactly. Any others? Okay. So then, today then, I just want to spend the day talking about the normal curve, talking about the area under the curve. So that we can look at area under the curves, find them, understand them, and look at probability distributions. Okay? So I've given you, everybody should have a table of positive, negative z-scores. And I always get this question, and I think, where did that question come from? Well, I have this on the test. I am a reasonable person. I wouldn't make you memorize this chart. That would be ridiculous, right? So I just wanted to spend the rest of what we have today in learning how to use the chart and learning how to find areas under the curves, okay? So I'm just looking for some problems, but so let's think about what we already know about the normal curve. We already know the curve is symmetrical. We already know that the total area under the curve is what? 1. 100%. 1. Okay? We also know that right smack in the middle, we know that it could be X bar, which would be a sample, mean. We could have mu, which is a population mean. And then we also introduced the concept of z-scores, didn't we? And we said right here, z is equal to 0, correct? Okay, because z really kind of measures the distance away from the center. We also went ahead and we split this up. We said we have a z of 1, 2, 3, and we have a z of -1, a z of -2, and a z of -3. And we looked at that. We looked at different populations. We talked about IQ scores, right? Did we do IQ scores in here? And we looked at that normal curve. Now we have to put this next step on, which positive and negative z-scores. Positive and negative z-scores. Because this chart is going to show us the area under the curve. Okay? We already learned that in a normal distribution, we have 68% or 34 and 34, right? We also learned that this is going to be 95% and this is going to be 99.7%. Those are what we already have in our memory, we already know about. But sometimes that's not exactly where our individual may fall. So I may say, I want the area under the curve for where z is less than 0.25. And I'm going to tell you the best way to do all of these problems is to draw the normal curve every single time. Picture says 1,000 words. Okay? So if I gave you that question, 0.25 would be between what? 0 and 1. Right there. And what does this say? Where z is less than, right? Less than. Well, if this 0.25, where is less than? To the left. To the left. So I'm trying to find the area under the curve of where that's highlighted. That's the area I need to find. When I look at 0.25, is it a positive number or a negative number? Positive number. So I'm going to look at my chart on the positive side of z-scores. Okay? And the way you're going to read this is down the column, the very first column, it says z. And it has 0.0, 0.1, 0.2, 0.3, and so forth, all the way down, correct? So I'm going to go to 0.2, but then I'm going to go over the columns until I see above the column 0.05. So I'm going to see 0.2, and I'm going all the way over until it says 0.5 over it. And if my old eyes can read correctly, it's 0.5987. Does everybody see 0.5987? If you don't, ask your neighbor to show you how. 0.25. Now, so I looked up that z-score, and it was nice and comfortable because the chart's going to give me exactly what I've highlighted on the board. Because this chart is going to give me the area under the curve. You can see the shaded here. From the very end, from the left to the z-score. It's always, this chart will give me from the left to the z-score. That's what my table is going to give me. So that one was a real nice, comfortable one, because that's the area I asked you for, from the left to the z-score. Right? That's reading the chart. That's not bad, right? Okay. So now I'm going to ask you the area of the curve where z is greater than 1.05. With the area under the curve. For the z's, where z is greater than 1.05. The first thing you should do is sketch that curve. I actually have a PDF that is attached to Blackboard, and I think I might have 6 on a page, and there's the back page too, so you can print them out so you don't have to draw them every time. It's all printed, just a blank normal curve, so you can just go. Okay? Okay? What do we know? Let's go ahead and put z at 0 right here. And I like to do that because I can't tell you how many times. I can't tell you how many times because I probably lost count. Where students will confuse a positive z-score and a negative z-score. Students will, I'll say it again. Students will confuse a positive z-score and a negative z-score. Negatives are always on this side, right? Positives are always on the right-hand side, correct? Okay, so now I want the area where it's going to be the z is greater than 1.05. So if I put my, there's 1, there's 2, there's 3. We can go ahead and do negatives if you want. First, let's sketch where 1.05 is going to be. It's going to be just past the 1, right? Because it's bigger than 1. And I like to label it because it assures me it's a positive z-score, it's in the right spot. So which area am I shading now? To the right. Because what? C is greater than this. Well, if I look at 1.05, where does z get greater? Where does it get to be larger? To the right. Okay? So I'm going to shade that. This is the area I want now. That's not what my chart's going to tell me. It's going to tell me to the left, isn't it? Right. Absolutely. You got it. You got it to go. Okay. But a lot of you are going, what was that about, right? So when I use this chart and I look up the z-score of 1.05, everybody do that. Is that a positive? We're going to look at the positive side. I'm going to go down to 1.0 and I'm going to go across to 0.05, and I'm looking and I see 0.8531. Everybody sees 0.8531. But what area is it telling me? It's telling me the area to the left, isn't it? So it's this area. So this area is 0.8531. So to find out this area, it's like the complement, isn't it? It's like the other side. So I'm going to take 1 minus 0.8531, and I'm going to get 0.1469. So this is the answer, because that's this area. Doing okay? This part is so crucial to understanding the areas under the curves. Okay?
So what is the 1.05 for? It's the final because we need a label.
Yeah, because that tells me what I want. That's 1.05, and what do I want? Greater than. So I want these. That's still my dividing line, if you want to think of it as your dividing line.
I just wanted to, now we got these two different numbers. Really like the area of it.
Yeah, because the area that it's giving me from my chart is this, 0.8531. It's the red area, because my chart only gives me from here to here. And I want the opposite. I want that side. Okay? Let's do another one. We can do these and do these and do these. You try it. You try it. Okay, so I want to find the area under the curve where z is greater than negative 0.75. Well, let's go ahead and label some stuff on our curve here. So remember, we keep ourselves straight as to where we are on the curve. Okay. Negative 0.75. Where is negative 0.75? Between where and where? 0 and negative 1, right? So, right about here, does everybody agree with that? Now, it says I want where z is greater than. Look at my z's. Down here, my z's are negative 3, negative 2, 0, 1, 2, 3. Where does z become greater than negative 0.75? To the right. To the right. Because isn't 1 more than this? So this is the area I'm talking about. Okay? When I go to my chart, I'm looking at negative scores, aren't I? I'm not looking at positive scores. I'm looking at negative scores. So I'm going to go down the column till I find negative 0.7. I am really stuck on 5s. I'm going to have to start using 5s. Negative 0.75, and I'm looking at 2266. Does everybody see 0.2266 for negative 0.75? What area is that? This little area, isn't it? Because my table gets me from the end to the z. So that area is 0.2266.
Yeah.
I'm going to say I forgot already. 0.2266. But that's not the area I want. I want this area. So 1 minus this, because I know the whole area under the curve is 1. So it's like, again, it's like using that complement. So I'm going to do 1 minus 0.2266. And we'll get 0.7734. And this is that area. You just have to answer the question. You just have to answer the question. But drawing it makes you see it. So you're not confusing positive z's and negative z's. And then what happens is we throw in areas. And students will get confused if I'm looking up an area or if I'm looking up a z-score. And there's a definite difference. Area is always positive. I can't have a negative area. that doesn't exist except for maybe out in some other galaxy besides us. We can't have a negative area. So my areas are always positive, but my z-scores can be positive and negative. Okay? So not too bad? Okay, here comes the challenge. You know it. We can't stay at the baby problems, right? So what is the area under the curve where z is greater than negative 1.37 and less than 2.82? I'm going to let you struggle with that for a second. See if you can think it through and think it out. Okay, hopefully everyone drew the curve. So it's asking for the area between negative 1.37 and 2.82. So first let's identify the area. Negative 1.37 is going to be between negative 1 and negative 2. So right in here. 2.82 is going to be between 2 and 3, closer to 3. And I want the area in between. So, knowing that my chart only gives me the area from the very left to the z-score, what do you propose that I'm going to do to get that area? Anybody? Excellent. So let me restate that. Because I want this area in between, the first thing I'm going to do is find the area from the end, the left, all the way to 2.82. I'm going to find that area. Okay? Somebody tell me what that area is. That's a positive, right? Positive 2.82. 0.9976. Okay? But that's the whole area, isn't it? All the way from here, all the way to 2.82? I don't want that. I want that area, but I don't want this area, right? So I'm going to find this area out from the left to negative 1.37. I'm going to find out what this area is. So I'm going to go back to my negative side. 1.37, which is 0.0853. So I'm going to take this whole area, which was 0.9976, but I'm going to subtract away this part that I don't really want included. So I'm going to subtract away 0.0853. 0.9123 is this area. See a lot of deer in the headlight look right yet. We'll do another one. So we're going to find the area between where Z is negative 1.20, and where z is 2.58. The area under the curve from negative 1.20 to 2.58. I'll pause. Okay. After you've done several of these problems, you probably get now why I gave you a PDF of several of the already drawn curves, because you're going to draw it 1,000 times. So I've got to first mark off my area I want. From negative 1.20, negative 1.20 is between negative 1 and negative 2. And then it's going to go to 2.58, which obviously is between 2 and 3. And I want the area in between. Okay? Okay? I can never just subtract z-scores. I have to subtract areas. I have to subtract areas. So I'm going to look at the area from left to the z-score of negative 1.20. That would be this area, wouldn't it? This is the area I don't want. Okay? Then I'm also from the left to this area of 2.58. Okay? Somebody tell me, look at your chart, negative 1.20, what is this area? Say it again. 0.1151. Everybody cool? Everybody agree with that? Okay? That's that area. But the next area I find for 2.58, it's going to include this same area, isn't it? It's going to go from here to the very left-hand tail all the way over to 2.58. And when you do that, what is that area? 9951? But this big area includes this area I don't want, doesn't it? Yes, so I'm going to take 0.9951 and I'm going to subtract away 0.1151. Wow, how did I pick those numbers? Maybe I should play the lottery tonight for sure. I'm going to get 0.8800.
I have a question for you.
Mm-hmm.
How are you going to get for the green part? Like, where do you, like, yeah.
Okay, so I'm going to go to my table, and because this is a negative z-score, I'm going to look down and find negative 1.2, negative 1.2, and since it's 0, I'm just going to go to that first column.
You're saying right here?
Negative 1.2,
Oh, I see. Okay.
and then it's 0, so I'm going to go right there.
Okay, and then that's that way.
Yep. Okay?
And if you look at the top, it shows you that
Yeah.
this is showing you the shaded in area, so it's showing you everything to this left, and then the same thing on the front, it shows you, it's showing you this area that's shaded and everything that's to the
Good.
left.
Yep.
So if you look at the picture on the top, it kind of helps you comprehend.
Okay? Yes.
So I understand where you're at 29.51. But my question is, you wouldn't subtract that from 1 because, you know,
Okay, so if I subtracted it from 1, if I took the area from the left tail all the way to here, 0.9951, and I said 1 minus it, I'd get this little area up here, wouldn't I? So because this includes this whole thing, let's draw it this way. I know this is a really crappy looking drawing. When I look up 2.58, that's the area we're talking about, isn't it? From here all the way over. But I don't want that whole area. I only want the area from negative 1.2 to 5.8. So what I'm doing is I'm finding this area and I'm cutting it away. I'm taking it away.
I'm not there for the first one that we just did. So now you got the whole thing. I feel like I subtracted it from the one, so what I was doing was at the end of the 1 minus 0.9951 minus 0.0049.
But I don't want this area.
But for the last one, we did want that area. Maybe that's where
No, the last one we did was we took the whole area to 2.82 and subtracted away this little area. What you're getting confused with was back, yes, where Z was greater than, I found this little area, but I wanted this whole area, and I said 1 minus that. The chart is from the left and not from the right. It never gives you the area from the right. It never gives you the area between two Z's. We have to find those areas and make adjustments. Okay? No, not 0. You knew that the area couldn't be 0 because we colored it in, right? Right. Okay, I know that's a lot to think about, but I wanted you to start thinking. Yes, once you get going with it, it's better. Remember, your test is... And I'm going to release the quiz, and the quiz will be due before you come to class on Wednesday. Okay? All righty.
Awesome.